Chemical reactions stop when one of the reactants is used up. Stoichiometry is the study of quantitative relationships between the amounts of reactants used and the amounts of products formed by a chemical reaction. Stoichiometry is based on the law of conservation of mass, and the mass of the reactants must equal the mass of the products. The particle and mole relationship. Here we have the chemical reaction, and we must interpret it in the terms of particles, moles, and grams, and then show the law of conservation of mass. First of all, let's show the particles. We have 4 atoms of iron plus 3 molecules of oxygen, and will give us 2 formula units of Fe2O3. On the mole level, we have 4 moles of iron and 3 moles of oxygen will give us 2 moles of Fe2O3. On the grams level, we must find the molar mass of each and multiply it by the coefficient available to get this. And after all, when we add the masses of the 2 reactants, it will equal to the mass of the product. The reactants and products must have the same masses to fulfill the law of conservation of mass. Using stoichiometry. All stoichiometric calculations begin with a balanced chemical equation. We have 3 types of stoichiometric problems. The first one is mole to mole, the second one is mole to mass, and the third one is mass to mass. The molar mass of oxygen is 16. 16 times 2 is 32. 32 times 1.35 will give us 43.2 grams of O2. The mole to mass. How many grams of O2 are required if 1.8 moles of iron is used in the reaction? The first step is to balance the equation by placing 3 in front of O2 and 4 in front of iron. The second step is to determine the moles of given substance. So the question says 1.8 moles of iron is used, so NFE equals 1.8 moles. The third step is to convert moles of given substance to moles of the unknown. So we place the 1.8 moles over 4 equals a number of moles of oxygen over 3. Then we cross multiply to get the number of moles of O2, which will be 1.35 moles. After that, we have to convert the moles of the unknown to grams by multiplying by the molar mass. The molar mass of oxygen is 16. 16 times 2 is 32. 32 times 1.35 will give us 43.2 grams of O2. The mass to mass. Determine the mass of N2 produced from decomposition of 90 grams of NaN3. The first step is always to balance the equation. NaN3 will give us Na plus N2. We balance the equation by placing 2 in front of NaN3, 2 in front of Na, and 3 in front of N2. The second step is to determine the moles of given substance. We get the moles of the given substance by dividing the mass given by the molar mass of the given substance. We have the mass of NaN3 is 90 grams, so we'll divide 90 grams by the molar mass, which is 23 plus 3 times 14. The answer will be 1.38 moles. The third step is to convert the moles of the given substance to the moles of the unknown substance. We do this by placing the 1.38 moles in a proportion to get the moles of N2. So we replace, then we cross multiply to get the moles of N2, which will be 2.07 moles. The fourth step is to convert the moles of the unknown to the grams. We do this by multiplying the moles of the unknown substance by its molar mass, which is 14 times. The answer will be 57.96 grams of N2. Identifying the limiting reactant. In this example, we have 200 grams of sulfur reacting with 100 grams of chlorine, and disulfur dichloride will be produced, and we have to find the limiting reactant. This is the chemical equation. The first step is to balance the equation. We balance the equation by placing 4 in front of Cl2 and 4 in front of disulfur dichloride. The second step is to find the moles of each reactant. We do this by dividing the mass by the molar mass of the substance. For example, NS8 will be M over M capital, which is the mass given 200 over its molar mass, which is 32 times 8. And the answer will be 0.781 moles. For NCl2 it's the same, M small over M capital. It will be 100 grams, which is the mass given, over 35 times 2, which is its molar mass. The answer will be 1.42 moles. The third step is to compare the number of moles to know the limiting reactant. Here we have NS8 over 1, which is the coefficient in front of it, is maybe equal to NCl2 over 4, which is the coefficient in front of it. We replace the values, NS8, which is 0.781 moles, and NCl2, which is 1.42 moles. We get the values, and the smaller value will be the limiting reactant. So Cl2 is the limiting reactant in this equation. Thank you for watching, and I hope you've learned something from this video.